Here in example 4, we're going to solve our first problem dealing with the angle of elevation. The angle of elevation from a point on the ground that is 15.5 meters from the base of a tree to the top of the tree is 60.4 degrees. So essentially what we're saying is that I have a tree here and my horizontal is the point. If I was standing right here and I was looking straight ahead, that would be my horizontal. And the angle of elevation means I'm going to start there and I'm going to look up and I'm going to look to the top of our tree. This would be called our angle of elevation, and it is 60.4 degrees. So what we want to know is what is the height of our tree, and since we don't know that, we'll call that x, and we have this right triangle that we have formed. And it says that the point on the ground is 15.5 meters from the base of the tree, so we also have that information. So we have a right triangle, we know one angle, we know one side, and we want to solve for x. So we know the adjacent side to the angle, and we want to find the opposite side. So adjacent over, or opposite over adjacent, that would be tangent. Tangent of 60.4 degrees would be equal to the opposite side divided by the adjacent side. And we're going to set up a trig equation using our two knowns and one unknown. So use your right triangle definitions of your trig functions to form a trig equation with one unknown and two knowns. And we're going to solve this for x. We're going to multiply both sides by 15.5, and this cancels, and we end up with 15.5 times tangent of 60.4 degrees is equal to x. And we're going to go ahead and put that into our calculator, and we're going to solve to the nearest tenth. So I get x is equal to 27.3 meters. And make sure that you can put that into your calculator and make sure that that is the answer that you get. In example 5, we are asked to actually find the angle of depression if we are standing at the top of a 97-foot tall building, and we want to find the angle of depression from the top of the building to the base of the building across the street. And we are told that that building across the street is located 42 feet away. So we're going to draw a picture here. Here's our building. And it says from the top, so we're going to pretend like we're standing at the top here. And the first thing I want to do with an angle of depression or elevation is to first establish my horizontal. So going straight across from the top of the building, here is our horizontal. So we want to establish that first. And then it says the angle of depression from that horizontal, or looking down from there, is what I'm actually going to be looking for. This is my angle of depression. We'll call that angle D. And we are looking down to the base of a building that is across the street. A couple of things. The building that we are standing on is 97 feet tall. And of course, if I look over here, that would mark off 97 feet from the horizontal to the base of the building. We're basically forming a rectangle here. And we're also told that the building is 42 feet away. So we have 42 feet here, as well as 42 feet across the top of our horizontal. So the building, from building to building, 42 feet. And we have our little rectangle here that we can use to help us solve. And we have basically formed two right triangles. So we want to solve for D, and we know two sides of this right triangle. So we want to solve for D. And I know the opposite side and I know the adjacent side. So once again, it looks like we're setting up tangent. Tangent of angle D is equal to 97 divided by 42. So the opposite divided by the adjacent. Now I would like to solve for the angle. And we remember that if I want to solve for the angle, then I'm going to have to use my inverse function. So we're going to type into our calculator tangent inverse. We're going to feed it the function value, and it will spit out for us the angle. We're going to go ahead and round to the nearest whole degree. So I get D is equal to 66.6 degrees, but I'm going to go ahead and round to the nearest whole degree. So we're going to say that the angle of depression is 67 degrees. In our last example, we are given a diagram, and we are told that from a window that is 29 feet above the street, the angle of elevation to the top of the building across the street is 46 degrees, and the angle of depression to the base of the building across the street is 16 degrees. We are asked to find the height of the building across the street. So first of all, let's form our perspective. Here is our window, and it's 29 feet above the ground. When I look out my window straight across, this would be what we would call the horizontal. So we're thinking about from the perspective of this window, here we are marked off and given the horizontal. Now we are told that this window is 29 feet above the ground. So from the ground to that horizontal, this would be 29 feet. And we are told that from the perspective of this window, if I look up to the top of the building across the street, that this would be 46 degrees. This is our angle of elevation. And from the perspective of the window, if I look down to the base of the building across the street, that would be what we call our angle of depression. We want to find the height of the building. Well, we have two triangles basically formed, two right triangles. So here's my right angle for the bottom triangle. Here's my right angle for the top triangle. In the bottom triangle, I know two things. I know the angle of depression, and I know actually the right angle, and then I know a side. I know a length of the side. In order for me to find the height of the building across the street, we're going to have to work with both triangles, because what I ultimately want to know is what is the measure from the horizontal to the top of the building. Let's call that a y value. Let's call that y. So in order for me to solve for that, well, in that top triangle, I only know one angle, and I don't know any sides at all. And in order for me to set up a trig equation, I can only have one unknown. That would force me to have several unknowns, at least two at a time, and so I'm not going to be able to solve for y directly. We're going to have to form some sort of link from these triangles. What we would like to do is find the length of the horizontal. It's the side that they share. Let's find the measure of that. Let's call that side x. So looking at our bottom triangle here, we have our angle 16 degrees, and from the perspective of that angle, I know the side that is opposite of it, and I know the side that's adjacent to it. So we're going to set up a trig equation. Tangent of 16 degrees is equal to the opposite side, so that would be 29, divided by the adjacent, which we don't know, we'll call that x. And now we're going to solve for x. I'm going to multiply both sides by x and divide both sides by tangent of 16. So we get x is equal to 29 divided by tangent of 16 degrees. We're just going to put that into our calculator, and I get 101.135. Round to the nearest two decimal places here. So the horizontal here, the measure of that horizontal, we solve for x there. Now we know that the measure of that horizontal is 101.14. Now for my top triangle, I actually know the angle and I know a side, and now I can solve for that one unknown side of y. Okay, so from the perspective now of our 46-degree angle working within that top triangle, we know also again the side that's adjacent and the side that is opposite. So the y would be opposite, so we're going to do tangent of 46 degrees is equal to y opposite divided by adjacent, which would be 101.14. And of course, we are going to multiply both sides by 101.14. And we're going to put this into our calculator and let our calculator tell us what the y value has to be. And I get a y value of 104.73. Go ahead and round to the nearest tenth. So now I know that the top part of our building, from the horizontal all the way to the top, would be 104.73 feet. Now, what is the height of the entire building across the street? Of course, the height of the building would have to be from the base of the building to the horizontal, so 29, plus from the horizontal to the top of the building, which we found to be 104.73 feet. And when I add those two together, I get 133.728. And we'll go ahead and round this tenth again. So that would make this 133.73 feet. So the height of that building total would be 133.73 feet.